Now, the next video, this looks like one I did in class, except for I think I had a 2 here. F of x is equal to x plus cosine x. So now I'm looking at a trig function on the interval from 0 to 2 pi is what I decided to do. So I take the derivative and I get 1 minus sine x equals 0 and bring the 1 over, and that gives me x is equal to pi. I did my little unit circle here, and this is the ordered pair 0, comma 1. 0, comma 1. So I'm looking where the sign is 1, and that's at pi over 2, 90 degrees. Now on my interval from 0 to 2 pi, okay, that's the domain that's called a restricted domain. You know the domain of this function is all real numbers, but what we're doing is looking at the function from 0 to 2 pi, and pi over 2 somewhere over here. I'm going to test between it, or before and after that pi over 2. So I put that in my calculator, that's about 1.6. So I tried f prime of 1. This is my f prime number line. I put that in, made sure I was in radian mode, and I got positive. And then I put 2 in, because if that's 1.6, I'll put 1 on this side. So I'm picking 1 on this side and 2 on this side of that. And I'm getting 0.09, so that's positive and positive. And there's no change of sign, so there are no relative extrema or local extrema. If I say the word relative, it just depends on what book is being used. Sometimes it's called relative and sometimes it's called local. I'm remembering that this book says local. So let's see, f is increasing on, would be from 0 to pi over 2, union pi over 2, pi over 2 to 2 pi. And there are no local extrema. Let's take a look at the second derivative. If this is the first derivative, the second derivative is going to be, well, the derivative of sine is cosine, so that gives me negative cosine, divide by negative 1, and I get cosine is equal to 0. Now, cosine is equal to 0 at pi over 2 and 3 pi over 2. So we have our restricted domain, 0 to 2 pi. Here's pi over 2 and 3 pi over 2, and this is all about the second derivative. And I'm going to test values, and I wrote down this was about 1.6, this is 4.7, 3 pi over 2. So I'm going to try a value over here like a 1, as I did before, and a 2, and then I tried just a 5, 4.7. Let's try a 5. So I'm trying these different values just to see what the sign of the second derivative is. I put in 1, I put in 2, and I put in 5, and I got negative, positive, negative. So there was a change of sign. And remember that this is concave down. This means concave up. This means concave down. And a change of concavity is inflection. So I have 2 inflection points here. And I'm going to conclude f is concave down on the interval from 0 to pi over 2. So I'm just going from 0 to pi over 2, and then concave up from pi over 2 to 3 pi over 2, and then concave down from 3 pi over 2 to 2 pi. So f is concave down on these 2 intervals, concave up on this interval, and f has an inflection point, or inflection points, at pi over 2, and this one is your f of pi over 2. You plug it into the original function, and this right here, 3 pi over 2, 3 pi over 2, this is from plugging it into the original function, and I did that down here. So I took f of pi over 2 and put it into the one on the other page, which was x plus cosine x. And that's why I'm getting pi over 2 plus cosine pi over 2. I know cosine of pi over 2 is 0. So, oops, I wrote that right here. And that gives me pi over 2. And then I put 3 pi over 2 in, and I got 3 pi over 2. So, and that's where I'm getting these 2 ordered pairs. All right. I'm going to make another video that shows all looking at the graphs of these. Well, let's look now. Here we go. Let's take a look. You can always check every one of these functions. So I'm going to do this x plus cosine x. There we go. Plug that in. Make sure I'm in radian mode. And then my window is from 0, enter, to 2 pi, enter. That was the interval that they wanted. And then I'm going to do the zoom fit to fit that window. Look at that. All right, so you can see the function increases and then decreases and then increases here. And then I'm looking at the concavity. This is concave down, concave up. Apparently there's another concave. What's it say? It says concave down. So concave down. That's right. It's like a frowny face, concave down. And then concave up. So you can see that it's kind of becoming a smiley face here, concave up. And then it goes concave down somewhere. It looks like about right there. And you can't find these on here. So you could check to see if the value, so if I hit second, calculate a value of pi divided by 2, that is indicating the inflection point right there. So I'm just looking at the values we got. And we also got 3 pi over 2, so if I second calculate a value 3 pi over 2, it's showing up here. So that is where the change of concavity occurs. All right, see you later.